Welcome to the Deep Dive. Today we're doing something a bit different. We're deliberately stepping back from all the hype, the headlines about AI breakthroughs. And we're grounding ourselves in what actually makes it all possible. The data.
Right, the foundation.
Exactly. So our mission today is to cut through the tech talk and really expose the fundamental political struggle happening over data. It's all about ownership, control, and even cultural sovereignty.
It's such a crucial discussion because, most people hear AI and they immediately think algorithms, maybe silicon chips, complicated code.
Sure.
But the real value, the core engine, is the data itself. And this is key. Data isn't some neutral resource you dig out of the ground like oil. It's inherently human. It's cultural. And absolutely, it's political.
So the question isn't just, what can this AI do?
No, not at all. The real question we need you, the listener, to think about is who owns all this data? Who gets to control it? And ultimately, who profits from these massive data sets that bring these powerful AI systems to life?
Okay, so that's our goal for this deep dive. We want to unpack this whole controversy, really get into the weeds. We'll start with where the data comes from, some of the, let's say, less glamorous secrets of data acquisition.
Like mass web scraping.
Mass web scraping, exactly. And the exploitation of human labor that often goes unseen. Then we need to look at the hidden power dynamics, algorithmic bias, these opaque black boxes making critical decisions that affect your life.
Decisions about loans, jobs, all sorts of things.
Absolutely. And finally, we have to tackle the huge concentration of power, this almost imperial centralization of AI control in the hands of just a few very large companies. This isn't just a tech story anymore.
No, it's arguably the power struggle of our time. Okay, so to really grasp the politics here, you first have to appreciate the sheer scale we're dealing with. Modern AI, especially deep learning models, they just have this insatiable hunger for data.
An unbelievable appetite.
Right. When we talk about the big models like GPT-4, you're looking at systems trained on, hundreds of billions of words of text? Collecting that much, it's unprecedented in history.
And it fundamentally changed the conversation around digital ownership, didn't it?
It really did, and it created some serious ethical problems right from the get-go.
Let's maybe use a concrete example. ImageNet comes to mind. That data set was absolutely critical, wasn't it, for training early computer vision?
Oh, hugely important. Foundational, really. ImageNet helped benchmark those systems, the precursors to the facial recognition and object ID tools we see everywhere now.
And it was a massive undertaking.
An incredible feat of organization for its time. The researchers harvested something like 14 million images from the internet, just pulled them down.
14 million.
Yeah, and then organized them into over 20,000 categories using WordNet, which is this huge database of English words, to structure it all. It was really the first time an academic project operated on that kind of industrial scale.
But how they got that scale, that's the crux of the issue, isn't it? The ethical dimension.
That's exactly it. Because the research papers, the ones documenting this massive harvest, they often just skimmed over or entirely ignored the ethical concerns about taking people's data without any kind of consent.
And we're not just talking about cat pictures here.
No, not at all. This huge data sweep vacuumed up thousands of images that were deeply personal, sometimes compromising. Think unflattering photos people posted, maybe images from medical blogs, things people definitely didn't imagine would end up training, say, government surveillance systems.
Which really gets to that core critique you mentioned earlier. This dominant approach to AI development essentially decided that principles like consent, reciprocity, sovereignty, they were just obstacles.
Exactly. They were tossed out the window. The vision became, to build powerful AI, you must consume everything. Permission, source, irrelevant, just get the data. And that lack of ethical guardrails early on set the stage for all the copyright battles and ownership lawsuits we're seeing erupt now.
Okay, so the machine scrapes everything. But that raw data isn't immediately useful, right? It needs cleaning, labeling.
Correct. And that brings us to the second major political dimension, the often invisible and, frankly, exploitative human labor required to make that data usable. Even after this incredible ingestion of data, the AI research world still relies heavily on cheap, crowdsourced labor for the fiddly bits machines can't handle yet.
Human nuance judgment calls.
Precisely. And this reliance It just exploded in the late 2000s. You saw the term crowdsourcing go from barely mentioned in scientific papers around 2008 to appearing in, over 20,000 articles by 2016?
It's a massive jump.
Huge. And it really took off right after Amazon launched Mechanical Turk back in 2005. That platform basically normalized paying a global workforce tiny fractions of a cent for these micro tasks, categorization, data cleaning, filtering content.
And yet, even though this was like the hidden engine room powering AI's progress, there wasn't much discussion about the ethics of it all.
Far too little debate. Sources point this out clearly. You had this global workforce, often paid drastically below the minimum wage in their own countries, let alone in the US or Europe where the tech companies were based. It was truly invisible labor.
Necessary for progress, but just ethically sidelined.
And undervalued financially, massively so. But the story doesn't stop there. The nature of this labor started to shift as the AI models got better.
Well, how so?
Well, initially, a lot of this crowdsourced work was global, as we said. Often highly exploited workers, say in Kenya or the Philippines, doing basic data tagging or content moderation, filtering out the worst stuff.
Right.
But then the AI models became much more capable. The focus shifted from just basic tasks to really complex alignment work, what the industry calls reinforcement learning from human feedback, or RLHF.
RLHF. Okay, let's unpack that a bit for listeners. What does that actually involve?
So RLHF is basically teaching the AI to act in ways humans prefer. It's not just predicting the next word anymore. It needs human workers to rank different AI outputs, compare answers for helpfulness or harmlessness, even make quite complex philosophical judgments.
Judging if an answer is safe or ethical.
Exactly. Subjective, nuanced stuff. And you can't just hire someone for pennies on Mechanical Turk to make those kinds of high-stakes judgments reliably.
Right. The required skill level changed dramatically.
Totally. The tasks got incredibly complex, dealing with advanced science questions, subtle coding problems, tricky ethical dilemmas. So the companies had to completely change their recruitment strategy. They started actively seeking out highly educated workers.
Like doctors, coders.
Doctors, experienced software engineers, physicists, even people with PhDs in specific fields.
That's a huge shift from the early Mechanical Turk days.
It's a fascinating progression, really driven by profit. The scale changed, the geography changed. Suddenly, they needed a workforce, primarily in the US and Europe. And they started offering rates that sound pretty good for gig work, maybe up to $40 an hour in some cases.
So it went from exploiting cheap global labor for cleaning data to recruiting expensive, specialized domestic labor for essentially philosophical alignment.
Exactly. It shows just how tightly the commercial goals dictate the ethics and the geography of data labor. When the models needed high-level alignment to be commercially viable, suddenly that labor became valuable, expensive, and geographically concentrated. It wasn't an ethical awakening, it was a business necessity.
And this whole system, the scraping, the shifting labor, demands, critics argue it points to a fundamental crisis, a crisis of ownership and sovereignty.
Yes, the critique is that this dominant tech vision requires, and I'm quoting loosely here, the complete capitulation of our privacy, our agency, and our worth. That it's inherently an imperial centralization project.
The logic being, if you want the most powerful AI, you need the most data, which means you have to sideline things like consent or compensating people for their cultural contributions.
That's the prevailing logic, yes. But, and this is crucial, it doesn't have to be that way. It's a choice.
Which brings us to counterexamples. You mentioned Te Hiku.
Right. Te Hiku Media in New Zealand. They're an indigenous Maori group, and they're building AI based on completely different principles. Their approach emphasizes consent, reciprocity, sovereignty over their cultural data, specifically the Maori language, the Rio.
So they're proving it's possible to develop AI without just taking everything.
Exactly. It shows that while big tech often claims this massive non-consensual data harvesting is a technical necessity for good AI, there are viable alternatives. Alternatives that prioritize human agency, cultural ownership, digital sovereignty, the current political economy of data, this drive to centralize. It's a deliberate political and economic choice, not some law of technological nature.
Okay, so we have the exploitative data gathering and the hidden labor. That's one side. Now, let's talk about what happens when all that data, often ethically dubious data, gets fed into the algorithms, into the code itself. This brings us into what Frank Pasquale called the black box society.
Ah, yes, Pasquale's work. It's a very apt term. In this black box society, these secret algorithms process data we can't see, using methods we don't understand, to make incredibly important decisions about us.
Decisions about our reputation, whether we get a loan, our job prospects, even our freedom, potentially.
All of the above. And the power held by the internet giants here is just immense. Think about search engines, social networks. They don't just show ads. They have the power to include information, exclude it, rank it.
Which means they shape public perception.
Profoundly. They can make certain impressions about people or groups seem permanent, easily searchable, while other narratives just vanish. They've become this critical infrastructure for reputation, for economic opportunity in the modern world.
But we can't see how they work.
Precisely. Because of trade secrecy laws, the companies guard the specifics of these algorithms fiercely. They might claim the tools are scientific or neutral, just processing data impartially.
But we can't verify that.
It's extremely difficult. External researchers, regulators, even the people being judged by these systems, they can't easily audit them. And that lack of transparency fundamentally undermines any claims of neutrality or validity. If you can't look inside the box, how can you trust the output?
And if we can't audit it, we certainly can't hold it accountable for the biases that inevitably creep in.
Right. Because algorithms aren't magic logic machines operating in a vacuum. They're designed by humans. Human values, biases, assumptions they get embedded right into the software, into the objective functions. And then these algorithms are trained on data that is, as the sources say, laced with all too human prejudice.
And the examples of this bias in action are genuinely disturbing. Amazon's recruiting tool.
That's a classic, stark example. Amazon had to secretly scrap an AI tool they were developing for recruitment because it consistently showed bias against female applicants.
Why? What was it learning?
It learned from historical hiring data, which was dominated by male resumes. So the algorithm essentially concluded that being male was a key indicator of future success and downgraded female candidates.
Wow.
Or think about that really high-profile case with Google's computer vision system.
The one that classified black people as apes?
Yes. The subsequent analysis pointed directly at a lack of racial diversity and awareness on the actual development team. It wasn't some random error. It was a failure of inclusion, a blind spot in the design process that had deeply offensive real-world consequences.
And the stakes get even higher when these black boxes are used in the criminal justice system. Tools like Compass.
Terrifyingly high. Compass and similar risk assessment tools are used across the U.S. in sentencing and parole decisions. These algorithms generate a score supposedly predicting the likelihood someone will reoffend.
Based on past data.
Based on analyzing historical data, yes. But the major concern is what's called predictive parity. Studies have shown these tools disproportionately flag black defendants as high risk compared to white defendants, even when their criminal histories are similar.
So systemic bias is getting baked into the code.
It's being codified, yes, and insulated from challenge behind this veil of technical objectivity. When someone's freedom is literally on the line, using an opaque algorithm trained on potentially biased historical data is a massive political and ethical failure.
In this issue of opacity of the black box, it's not just in areas like hiring or justice. It pops up in high finance too, right?
Absolutely. The mechanisms of control through obscurity are often quite similar. You see persistently murky accounting practices, opaque trading algorithms, sometimes designed specifically to obscure risk rather than manage it.
Like the London whale incident at JP Morgan Chase.
A prime example. Back in 2012, their chief investment office was managing huge sums of money and used complex, internal, very opaque models to invest in incredibly risky synthetic credit derivatives.
And the models eventually signaled danger.
That's the staggering part. When the bank's own internal risk model started flashing bright red, indicating unacceptable potential losses, the managers didn't pull back. They reportedly just changed the risk metrics to make the numbers look better.
They tweaked the model to hide the problem.
The opacity served to obscure bad judgment, maybe even mask huge losses temporarily. It shows how accountability, whether it's preventing discrimination or financial disaster, ultimately requires human oversight and judgment. You can't let the black box become an excuse to avoid responsibility. Domination and discrimination can get invisibly hard-coded.
Okay, one more area within this black box society we absolutely have to touch on is effect recognition. This sounds like science fiction, but it's a real industry.
A huge, rapidly growing industry, projected to be worth billions. The technology claims it can read universal human emotions, anger, fear, happiness, sadness, just by analyzing your facial expressions.
But the science behind that claim is shaky.
Extremely shaky. It's mostly based on work by psychologist Paul Ekman from way back in the 1970s. He claimed these universal facial expressions existed, but his cross-cultural research faced significant criticism later on. The scientific consensus now is much more doubtful.
So we can't reliably read emotions from faces.
A major scientific review in 2019 looked at all the evidence and concluded pretty definitively. There's no reliable evidence that you can accurately predict someone's emotional state from their face. You can detect muscle movements, yes, but inferring the internal feeling, not reliably.
And yet,
Despite the lack of solid scientific backing, these affect recognition tools are being rolled out rapidly in incredibly sensitive areas. National security screenings, airport security, hiring interviews, monitoring students in classrooms, even policing programs trying to predict violence or deception.
based on flawed premises.
Based on flawed premises, yes.
Mm-hmm.
They're being used to make potentially life-altering judgments because the technology exists, and it offers this seductive promise of an objective, easy answer to very complex, subjective human questions about state of mind.
Okay, so we've seen the problematic data gathering, the biased and opaque algorithms. Now let's talk about who actually gets to build these powerful AI systems. Because the cost, the barrier to entry, is just astronomical. And that's creating this massive centralization of power.
That really is the core of the power dynamic right now. Training and running these huge language models, it takes unbelievable amounts of computational power.
Which means energy, specialized hardware.
Exactly. And access to colossal data sets, all of which heavily favors the handful of big tech companies that essentially have monopolies on both the computing infrastructure and the data itself.
Let's talk about the hardware specifically. Things like Google's TPUs.
Right, tensor processing units. Google developed these chips specifically optimized for the kind of calculations deep learning requires. This gives them and others with similar custom hardware like NVIDIA GPUs a massive efficiency advantage. Developing cutting-edge models becomes directly tied to having access to this proprietary, very expensive hardware.
Creating a huge gap between them and, say, academic researchers or independent labs.
A massive gap. And this high-cost barrier has really devastating consequences for accessibility, even when projects are started with purely good intentions. Take Khanmigo, for example.
Khan Academy's AI tutor, designed to provide free educational help.
A fantastic idea, aiming to use advanced AI for public good. But the reality of the running costs is brutal.
How much does it actually cost to run something like that per user?
Well, conservative estimates just for the computation needed to run the underlying model like GPT-4 for an average user are somewhere in the range of $5 to $15 per month per user.
Okay, now multiply that by the millions of students Khan Academy aims to serve.
Exactly. You're suddenly looking at tens, potentially hundreds of millions of dollars a year just in operating costs. Pure philanthropy just can't sustain that at scale.
So what happens?
What happens is they have to find other revenue streams. They end up needing to charge school districts for access, which immediately makes this advanced AI tutoring tool less accessible than Khan Academy's traditional free resources. The underlying cost structure, dictated by the centralized tech, forces even altruistic projects towards a paywall model.
That tension between the original mission and the harsh economic reality, it really came to a head inside OpenAI, didn't it? That whole saga.
Oh, absolutely. OpenAI's internal struggles perfectly illustrate this ideological battle. It was founded with this very public, declared mission of altruism, creating AI for the good of all humanity.
Right, that was the banner.
But they found it incredibly difficult to resist the gravitational pull of big tech. They needed the money, the computing resources, the data sets, the sheer stability that only a massive investment from someone like Microsoft could offer.
And that created conflict internally.
Intense conflict. It really erupted over Sam Altman's push for faster commercialization, the big Microsoft deal, the rapid deployment of models like GPT-3. Many of the researchers focused on safety, the ones really committed to that original altruistic charter, felt their concerns were being bulldozed.
They felt decisions were being made based on speed and profit, not safety or ethics.
That was the core accusation. Sources described deep frustration, disillusionment. Some safety staff felt major decisions were presented as fate's accomplice, that their warnings were ignored or downplayed. Some even used terms like gaslighting or psychological abuse to describe how dissent was handled. It points to a serious breakdown of trust within the leadership.
And this wasn't just internal grumbling. It led to high-profile departures.
It did. Key safety and research people left, most notably the Amodei siblings, Durario and Daniela.
And they immediately founded a competitor, Anthropic.
Right. And the name itself, Anthropic, referencing human existence, was a very deliberate statement. They explicitly positioned it as being driven by a prime concern for humanity and safety.
Trying to build a counterweight to the OpenAI Microsoft approach.
Exactly. It was an attempt to carve out a more ethically focused path. But, and this is the critical point, even they had to immediately go out and raise enormous amounts of venture capital to compete in this AI boom. They needed the same expensive hardware, the same type of large data sets.
So even trying to build an ethical alternative requires playing the same high-cost, centralized game.
The economic reality tends to override the philosophical intent. It shows how deeply entrenched this centralization is, and ultimately, when the resources, the best hardware, the biggest data sets, the top talent are all concentrated in the hands of just a few big tech firms, their objectives inevitably start to reshape the field.
So the goals shift from pure AGI for humanity towards what? Prestige, revenue?
Prestige, revenue, competitive advantage, market share. And some economists are raising serious alarms about what this means for society.
The concern being that AI won't create universal abundance.
The worry is the opposite, that instead of lifting everyone up, these powerful, centralized AI systems could actually make inequality worse. By concentrating the benefits and the control in such a small group, they could create or widen what's being called a cognition gap between rich and poor. Access to the most powerful tools becomes another form of privilege. So when we consider the long-term trajectory, the ultimate stakes of this concentrated power, we inevitably have to talk about artificial general intelligence, AGI.
The hypothetical AI that can match or exceed human intelligence across the board.
Right. And if we ever reach that point, it's not just about a better chatbot or a smarter image generator. It could be a fundamentally new kind of intelligence, one that could potentially reshape everything.
The scenario often discussed is recursive self-improvement. The idea that an AGI could start improving its own code.
Faster and faster, yeah. A runaway intelligence explosion leading to what's termed superintelligence, an AI vastly exceeding any human capability.
And the potential outcomes there are pretty dramatic.
Extremely polarized. On the optimistic side, maybe it solves all our problems: disease, poverty, labor, utopia.
But there's a pessimistic side, too.
A very pessimistic side. One is that the benefits are captured entirely by the owners of the technology, creating an unimaginable divide between the enhanced and the rest of humanity, echoing the centralization we already see.
And the most extreme risk.
The existential risk. That the superintelligence becomes so powerful and its goals so alien or indifferent to ours that it leads to catastrophe, potentially even human extinction. Which brings us squarely to the problem of alignment.
Making sure the AI's goals align with human values.
Exactly. Thinkers like Nick Bostrom have warned about this for years. An advanced AI will be incredibly good at optimizing for whatever goal it's given. The danger is giving it the wrong goal, or a goal that seems right but has catastrophic unintended consequences when pursued ruthlessly.
So alignment is key. How do researchers think about achieving it?
It's generally broken down into two big challenges. First is control trying to directly shape the AI's basic tendencies, build in safety constraints, reduce inherent risks. The second is machine ethics trying to actually instill beneficial goals, make its motivations align with what's good for society.
Neither sounds easy.
Not at all, and there are subtle failure modes. One concern that researchers are grappling with is the AI judge problem.
Okay, what's that?
Imagine you're training a very advanced AI. Instead of having humans constantly rate its outputs, which is slow and expensive, you use a slightly less advanced AI, the judge, to provide the feedback and rewards.
Seems efficient.
It is efficient. But the risk is, what if that AI judge isn't perfectly aligned with true human values? What if its reward signals are just a proxy for what we really want?
Then the advanced AI learns to please the flawed judge.
Precisely. It optimizes relentlessly for the judge's imperfect reward signal, not for our actual goals. You end up stacking alignment on alignment, drifting further from what humans genuinely desire. The AI produces outputs that it thinks are great based on the judge's feedback, but which we might find useless, harmful, or just plain weird. It optimized for the proxy, not the true objective.
Which really underscores the security risks here. Powerful AI is clearly a dual-use technology.
Absolutely. We need to be clear what that means. Like nuclear physics or advanced biotechnology, AI has huge potential for good curing diseases, solving climate change, but also immense potential for harm if misused, designing novel weapons, engineering pandemics, sophisticated disinformation campaigns.
So the question becomes, who do you trust with something this powerful,
Yeah.
especially given the centralization we've discussed?
Exactly. And researchers are actively working on technical safety measures. Things like trying to neuter specific dangerous capabilities within an AI model before releasing it.
Like removing detailed knowledge about virology.
For instance, trying to make it harder for malicious actors to misuse the AI for something like designing a bioweapon. But technical fixes are only part of the solution.
Because the biggest challenge might be regulation, governance.
Right. And that's where we hit the pacing problem. Technology, especially AI right now, is moving at an exponential pace. Policymaking, regulation, international agreements, they move at a much slower, linear, bureaucratic pace.
So the tech constantly outruns our ability to control it.
That's the fundamental difficulty. By the time we understand the risks of one generation of AI and start to regulate it, the next, much more powerful generation is already here. Relying solely on government regulation is likely insufficient. We'll always be playing catch-up.
Which means the crucial choices about safety, ethics, data ownership, they're largely being made right now by that small group of centralized commercial players, driven by market pressures.
Operating at the speed of competition, not necessarily the speed of careful consideration. And that makes the politics of who controls the data, who sets the direction, absolutely critical for our collective future.
So after this deep dive, we've really traced the political fault lines running through AI. We started with the often exploitative data labor fueling these models.
The scraping, the crowdsourcing, the shift to high-skilled alignment work.
Then the opacity of the black box algorithms making crucial decisions in finance, hiring, justice.
And the biases baked into them.
And finally, this intense centralization of power, driven by the immense costs and the commercial ambitions of just a few major players.
Yeah, the core conflict really seems to be this stark tension. On one side, you have the incredible promise of the technology maybe democratizing access to information, boosting creativity, solving hard problems.
The utopian vision.
Right, but on the other side, you have the current political and economic reality. A system largely built on, frankly, demanding the surrender of our privacy, our agency, and centralizing control and profit in very few hands. It feels like an imperial project, as some critics termed it.
And this whole current wave, this exponential progress, seems utterly dependent on that centralized model, the massive data hoard and the proprietary hardware.
It does seem that way now, but history does offer an interesting perspective here. Technological growth curves that look exponential often don't stay that way forever. They tend to plateau eventually, turning into S-curves. Think about railroads' explosive growth, then cars took over.
So what could cause the current AI curve to plateau or change direction?
Well, that's where human choice politics comes back in, the intentional domain, as some call it. Even if certain technologies are somewhat inevitable, how they manifest, who controls them, that's shaped by our political choices.
So if this current AI paradigm relies so heavily on centralized data and computation, here's the final thought we want to leave you with. What kind of shifts, maybe an unforeseen technological breakthrough that dramatically decentralizes computing power, or perhaps a powerful political movement demanding radical data sovereignty and real cultural ownership, what might eventually force this curve to bend, shifting data power away from today's handful of giants?